going to focus on the properties of water. Okay, so it's taken us quite a while to get to water, even though we've been talking about, the classes, the ocean world, but we had to know how the basins and things formed before we could talk about the water that filled them in. So what we're going to focus on first is just how the structure of water and why it behaves the way it does. So we're going to look at some bonding, and then the properties that result as from that bonding. And then eventually we're going to get to water's role in weather and climate, which is really important. All right, so first a quick review of some chemistry. So we all know that water is made of hydrogen and oxygen, and every water molecule has two hydrogens bonded to one oxygen, which is why it's H2O. The reason the two bond together is because neither hydrogen nor oxygen is what is considered stable with its current electron configuration. Each hydrogen only has one electron in its outer shell, and it needs two to be stable. And each oxygen has 6 in its outer shell, and it needs 8 to be stable. So in order to become stable, hydrogen will share its electrons with the oxygen in a process called covalent bonding. So covalent bonds are formed when electrons are shared between atoms. So in this last image here, you can see how hydrogen shares its one electron, and oxygen will return share an electron with water. Okay, so water is formed through covalent bonding. Now, you'll see that we don't draw this in a straight line, and we're going to talk about why that is. So water actually has a bent shape, meaning the hydrogens are not located on directly either side of the oxygen atom. The reason this has to do with the extra unshared electrons on the oxygen atom. So hydrogen doesn't have any extra electrons here on the outside, but oxygen does. So this is what results in a bent shape. And we'll talk about again why this happens, but the resulting angle is about 105 degrees. You don't need to know this, but you do need to know that it is not a straight line. It is this bent shape or this angle that gives water a special type of chemical bond called the hydrogen bond. So let's just look at this more closely and why this ends up in this bent shape. So you can see here that there are electrons sitting on the outside of the oxygen atom, and it's actually the protons, which are positively charged, which sit on the outside of the hydrogen atom. So as a result, the oxygen part of this molecule becomes slightly negatively charged. It has a negatively charged region sticking out. And the hydrogens have a positively charged region sticking out because their protons are exposed and their electrons are pushed to the inside. So this results in what is called a polar molecule. A polar molecule has a positive region and a negative region. Okay, so polar just means opposites. And you can see here that the hydrogen end is slightly positive, whereas the oxygen end is slightly negative. This is also called a dipole, di meaning two and pole meaning ends. So it has two ends or two sides to it, a positive side and a negative side. So what do you really need to know so far from this? You need to know that water is formed by covalent bonds, and you need to know that it is a polar molecule. Okay, polar meaning it has a positive and a negative side, and you need to know that oxygen's the negative side and hydrogen is the positive side. So because it has two sides to it, a positive and a negative, it is attracted to other nearby water molecules that also have positive and negative sides, because we know that opposites attract. So the positive part of one water molecule is attracted to the negative part of another water molecule. And this forms a temporary bond called a hydrogen bond. Hydrogen bonds are not nearly as strong as the bonds within these molecules. Okay, so the bonds that connect hydrogen and oxygen to each other are extremely strong. Hydrogen bonds are weak. Okay, they're strong in terms of what we call inter molecular bonds, but they are still overall very weak. And they actually break apart and reform all the time, whereas the bonds within the molecule do not. Okay, so hydrogen bonds are temporary, but they do form, and this causes a significant effect on the properties that water has. One of the most important factors that affects hydrogen bond formation is temperature. So this is very important. Temperature affects whether bonds are broken or whether they form. At high temperatures, molecules move around a lot more. Okay, they get excited by the energy and they move around more. So do you think there are going to be more or less hydrogen bonds at high temperature? What do you think? If the molecules are moving a lot, do you think these bonds are going to form? Audrey? No. Okay. So she's correct. The more the molecules are moving, the less likely they're going to be bonded to each other. Okay. So high temperatures result in breaking of hydrogen bonds, and lower temperatures result in more hydrogen bonds forming, again, because the molecules slow down their movement at low temperatures and more of these bonds can form. And this is going to play an important role in a lot of the things that happen in ocean water, which we'll get to a little bit later. So when these when these water molecules connect using hydrogen bonds, they usually will connect in like strings, or sometimes they can even form complete clusters. And again, it has a lot to do with the temperature. So when it is water or a liquid, we'll see more of a string-like structure. Whereas as it gets colder, when it's ice, we'll see them even more clustered together because more hydrogen bonds have formed, and they'll actually form like a hexagonal shape. The term you probably talked about in biology was cohesion. Cohesion just means a water molecule is attracted to another water molecule. Okay, so that hydrogen bonding causes cohesion. Water is the only substance on Earth that has some of these very unique properties that we're going to talk about, okay? And it is all a result of this hydrogen bonding and cohesion. All right, so now we're going to go over some of the various properties. These you, I'm sure, talked about in biology. Whether you remember them or not is another story. Okay, so the first unique property of water is it has very high surface tension. This is what causes the shimmery look to water when you look at it. And also on this mug here, it's what makes it look like the water is going to overflow its edges, but it doesn't unless you touch it and break that surface tension. So how does hydrogen bonding contribute to this high surface tension? So again, water is attracted to other water molecules, cohesion. But when water molecules come to the surface, there is only air on the other side and not water molecules. So what they do is they turn or orient themselves so that they are facing downward to try to attract the other water molecules. This actually results in a pulling down effect. Okay, so that's why you see the edges pull down when there's edges to something. And it also creates like a thin skin or well, yeah, kind of think of it like a thin skin layer on top of the water called surface tension. So it's a pulling down effect. Okay, just for a little break here, here's some images of surface tension in action. So the reason water can form drops is because of surface tension. If you pour out alcohol or something, it will not form drops. So there's that stretching effect. Okay, you've probably also seen water striders in biology. I believe you floated paper clips on top of the water. And water striders can walk on water because of surface tension. This is a peaceful video, so I'll let it play. Okay. Oops. Okay, the next property that is very unique to water, there are some other substances that do this, is its dissolving power or its ability to dissolve certain other materials. One of the things that everybody knows dissolves in water is salt or table salt, okay? The reason table salt dissolves is it's because it's something called an ionic compound. So let's take a look at what an ionic compound is. So here's basic table salt with sodium and chlorine. And an ionic compound is just another way of bonding. But instead of sharing electrons like water does, there's an actual exchange or transfer of electrons happening. The goal is still the same for each atom to become stable, but this process happens by the movement of electrons instead of sharing. So if we look at sodium, sodium's electron configuration shows that sodium only has one outer, also known as valence electron. Okay, this is not at all stable. It needs 8. Chlorine has 7 in its outer shell. It also needs 8. So the easiest way to accomplish this is for sodium to actually donate its electron or transfer it to chlorine, which would give chlorine a stable outer shell. And by sodium losing its 1 electron, its next shell down is already full. It's already got 8. Okay, so that will accomplish the stabilization. But when this happens, these two atoms, because they have gained or lost electrons, form ions. And an ion is just an atom that has a charge. So sodium, because it lost an electron, actually becomes positively charged. And chlorine, because it has gained an electron, actually becomes negatively charged. And the compound is formed by those opposite charges holding together. Now, that's a lot of information for those that have not had chemistry. So here's the main takeaway. Because ionic compounds also have a positive side and a negative side, okay? Again, one lost electrons, it becomes positive. One gained electrons, it becomes negative. It acts like a polar molecule, okay? So water is polar and ionic compounds are polar. So any ionic compound is considered polar and can be dissolved by water. I want to point out an important term here, and that is the term salt. So when I say salt, most people just think of like table salt, okay? But the term salt applies to any ionic compound. So any polar compound formed by the transfer of electrons. So when we start talking about salt in seawater, it's not just going to be sodium chloride. There's going to be lots of ionic compounds in there. Okay, so you need to understand that salts are polar and they have a positive and negative side. Now, how does the dissolving happen? So the reason ionic compounds or salts can be dissolved by water has to do with the polarity. Okay, so because water is polar and ionic compounds or salts are polar, the water is able to come in and break apart the pieces that are in the salt because of their negative and positive charges. So I'm going to show the video here that will show you how the water comes in and the negatives will attract to the positives and the positive will attract to the negative. So here's a video. It's the best way to see it.
Sodium chloride crystals are
Do I have the sound on? Yeah, okay.
held together by attractive forces between the positively charged sodium and negatively charged chloride ions. When a crystal of sodium chloride is placed into water, the hydrogen ends of polar water molecules attract the negatively charged chloride ions and gradually surround them. Likewise, the oxygen ends of water molecules are attracted to and surround the positively charged sodium ions. The hydrated ions drift away into the solution, allowing new water molecules to surround newly exposed ions. Gradually, the entire crystal dissociates into solution.
Okay, so they use the term dissociation there, okay, but dissociation just means dissolving. So salt is dissolved by water because it's pulled apart. Okay, one last thing here. Where's my, okay, so we'll do one last quick property. This one's easy. Property number 3, water is a liquid at temperatures normally encountered on Earth, okay? So water is one of only 2 hydrogen-based compounds that's actually a liquid at what we call room temperature. Room temperature is about 20 degrees Celsius. So you can see here that water at 20 degrees Celsius is a liquid. The only other one is hydrogen fluoride, but even here you can see that it's really not in the range of what we normally see on Earth. Okay, and this is just very important because all living things on our planet are made of water. So without these special properties, water would not be a liquid and hence life could not exist. Okay, that will be our last thing for today. I do not have any assigned work for you this afternoon, so you can focus on your other classes.